Welcome to Data 6330's presentation on glider data preparation for the World Cup. My name is Richard Hoehn. Introduction. We have been employed by the Swiss Gliding Society to review data for the upcoming World Championship in Uvalda, Texas. Our problem is we want to find, based on regions, what the best points are, flight times, aircraft. We would like analysis on the aircraft's optimal takeoff times, and we would like to identify times of day for the longest or highest pointed flights broken down in region. I want to note this is a fictitious project created for this class. It's not real. Our agenda is data cleansing, feature engineering, and exploratory data analysis. We're going to jump into visualizations for better data understanding. We're going to then go into detail and analysis for our problem formulation by using a regression analysis to find the estimated points and a cluster analysis to find the optimal takeoff time for flights. And we're going to end with conclusions and business insights. So data cleansing is, most importantly, we got Excel files on a daily basis. The day is actually in the file name that had to be extracted, and the columns of the Excel sheets held points, name, distance, the speed, the club, the region, and the takeoff and landing times. We imported over 13,000 flights, which had to be cleansed. So we removed non-pointed flights, we removed bad data, odd wingspans, regions that were missing, and I ended up with about 10,000 flights all in all. We then went into feature engineering. One of the important ones is extracting the region. Another important one is to extract, is this Uvalda or not? As you can see in the image, we can now highlight in orange if it's Uvalda or not to kind of find information. Once we had that, we really went in exploratory data analysis. So very interesting part is distance versus points is much more correlated than, say, speed versus points on a flight. And another part was looking at the regions. Not all regions are created equal, and we can really see this in our data. Some regions you can really get a lot more higher pointed flights than in other regions, which was really exposed by the pair plot analysis. So going into our visualizations, some were valuable and some less valuable. The not so valuable ones really showed that the wingspan didn't have a very big effect on points. As you can see in the graphs here, 15 meters versus 20 meters are all about the same, even though there are a big difference between each other. Similar June, July pointed flights are very similar to each other, and therefore the year-month details weren't as important as others. However, takeoff and landing, when we visualized it, we really could see that overall in all the regions, a takeoff time about 1:30 in the afternoon was optimal. When we looked at Uvalda only, we kind of noticed that it was about half an hour earlier that the region was more important. But we also noticed that when we graphed the red line at 410 points, which was an average, we saw that Uvalda's region actually got less points. Same as when we look at aircraft, we noticed that certain aircraft get you more average points than others. So we graphed the top 10, and we could really see also that certain aircraft are used more than other aircraft in general, kind of thing, which was interesting. Then when we looked at regions from a visualization, we could see US 11, top right, is very high, whereas Uvalda, the purple US 10, is kind of in the middle of the pack. Not too bad, not too good, just in the middle. But we did see that Uvalda's US 10 did have lots and lots of flights associated with it, which also told us that it's a good region to work with. So for our analysis, we had to go back to our problem formulation, and that was comparing the flights based on points of the regions. We need to figure out an optimal takeoff time and identify the best times for the longest flights based on regions. To solve that, we really use two things. One is regression analysis to get an estimated points based on known features, and using a clustering analysis to group these flights to figure out the best takeoff time. So our regression analysis really showed us that our residuals were pretty good. We used month, year, region, aircraft rank, speed, and time of day. We got a 0.43 R squared out of it, which indicates that our model can predict based on our features at 43% the points. The learning rate seemed to be very good, which you can see on the lower right, where it got pretty stable in terms of how well it predicted points. And with the residual plot, you can see that it was normally distributed. Very interesting, though, is when we said we're going to focus on a certain region, we jumped from a 0.43 to a 52% kind of thing when we just looked at Uvalda. So this really tells us when we're looking our regression analysis and our model to get a point prediction, we need to hold certain things steady, which makes sense, right? So we know that we're in region 10, or we know we're in region 11, or we know what the time is. And based on that, when we train our models, we can get much better point predictions. Second was clustering. And first, you need to kind of find the optimal cluster size, which we used an inertial model for, that turned out to be about 4 clusters. When we graphed our clusters based on takeoff time in minutes and the points, we could really see that low points were in yellow and at green, high points were in green to the right of the x-axis. Interestingly, when I created bounding boxes around these 2 clusters, they all pointed towards 1:30 in the afternoon, which can be indicated by the red line, which I thought was very interesting and kind of corroborated our other visualizations of 1:30 being an optimal time for takeoff. This gives us some good business insights. For one is takeoff time matters. Based on the visualization and clustering, the takeoff time is important around 1:30 in the afternoon. You can also use the clustering for known features to kind of focus in on areas. Second is region location matters too. The points vary really widely among regions, and therefore it's probably important to focus on the Uvalda region to make sure that we know that's where we're flying and that's what we're looking at. And then finally, pilot variability. Our models really showed that on the regression analysis, R squared of half or 50% is really not that great. But on the flip side, if you think about it, we are testing pilots in this competition, in this world championship. And so it's actually good to know that a good percentage of the points and how to predict them is still based on the pilot's ability to fly the airplane. And therefore, it's not just equipment, but only a certain portion of the equipment and how the pilots deploy this equipment that really makes sense and gives them the points. So summary and conclusions, takeoff time in Uvalda should be around 1 o'clock. We saw that based on the visualizations and the cluster analysis. The wingspan is not important for Uvalda. However, the takeoff time and the aircraft type are, so we should focus on that. And finally, Uvalda as a region doesn't always generate really high pointed flights. So if we get around the 400 point flight in Uvalda, we're doing very, very well. And with that, I am finished and I appreciate the time. Thank you very much.